Good morning. Today we start our first day, Algebra 1. We're solving 1 and 2 step equations. Now, I've always joked around that solving equations should be the number one thing for teenagers because you basically do the opposite of what you're supposed to. That's kind of what teenagers do all the time. Joke of the day. Today's joke of the day. Do you want to know what a acorn is? Well, in a nutshell, it's an oak tree. Okay, so we're getting into solving equations. Now, we always want to try to find our variable right here. That's what we're looking for. Now, I have some students, they'll sit here and they'll take like a highlighter or something, and they will highlight each of their variables so they know where they're at. All right, now, I know it's kind of hard to do that right now, but I do have the notes so you can print them out, or if you want to pause or whatever or copy them down, you can do that. Okay, that's all up to you. Now, let's look here at number 1. I'm trying to get m by itself. Well, 12 is being added to m, so I'm going to subtract. Minus 12. Now I got to do it to both sides, so this cancels. All right, and now I'm left with m equals -2. All right, that's it. That's my answer. I'm done. Now, I know I'm showing work. Some people are like, I don't want to show work if it's just one step. I totally understand. But we got to get you in the process because it does get harder as we go on. If you don't have the basis, you're going to be lost in the sauce. Okay, now, number 2, G is over here. Now, what is being done to G is 9 is being subtracted. Okay, we're not doing anything over here because it's on the other side of the equal sign. Some people say it's on the other side of the wall. All right, so I'm going to do the opposite of subtract 9, and I'm going to add 9. Now, if this gets to the point where you're like, I'm not very good in add, subtracting the integers, guess what? Use a calculator. If you don't use a calculator, you're fooling yourself. Okay, you need to use your calculator. Now, you could write it like this, or I know a lot of people will write it like this. Either way is fine. All right, so moving on to number 3. All right, on number 3, we look at -7 and y. So when they are side by side like this, we got to do the opposite. This means multiply. So the opposite of multiply is divide. So I've had a saying for years that if it's side by side, you must divide. Now, I'm not going to lie, this is not my first time recording this because I have messed up a lot because I'm human. And if you look at your little screen down here, yes, I am actually like a little person with my headphones because that's just me. I want to make sure you can hear me better, and bless your heart for having to hear me. So right here, I've actually used my calculator on this because this is not my first time recording this today. All right, now I'm going to scoot this up because, you know, my lovely face is over here in the corner. All right, so when we're over here, now it looks like a fraction. For years, I've said if it's side by side, you must divide. If it looks like a fraction, you multiply. So what we're going to do, this is actually division, and the opposite of division is multiplication. Now, I'd rather you use a dot. Please don't use an X, okay? The reason why, we're in Algebra 1 now. X's are variables, okay? If you just add X's all the time, you're actually doing something wrong, all right? So now we have A right here, and we have a negative times a positive, and that's going to be a -36, okay? So that's the first 4, not too off bad. All right, so let's kind of move on. Now, this is, I really hate, I'm not getting to do this face to face because this is one of my favorite things to teach on the first day. Okay, so fractions, to get rid of a fraction, you multiply by the reciprocal. Okay, that's basically the flipped form. Now, what I would usually like to do is I would take somebody, a volunteer per se, and we're just going to draw just a little stick figure right here. All right, and I would actually kind of take them and flip them upside down. I can't really do that right now because we're not face to face. And it was kind of funny. I actually had somebody flipped upside down as somebody came back in from the bathroom, and their first day of high school, they saw somebody upside down. But it usually makes people remember, hey, I'm going to take it and flip it. Okay. So, again, if you want to use your highlighter, I know I'm kind of cheating because I have all these cool tools, but this is not a bad thing. Some people do arrows or whatever, to each their own. Okay. Now, I've got to multiply by the flipped form. So I want to multiply by 3 over 2. Okay. Now, when I do this, yes, pew, pew, those cancel. I'm left with x. Okay. Now, a couple ways you could do this one. If you're doing it just with paper and pencil, you can multiply 10 by 3, divide by 2. Some people cross cancel. Again, I would use the calculator. Okay. I would use a calculator. If you type it in right, it's going to be right. Now, it's a simple tool. Notice I said type it in right because I have students who'll say, but my calculator gave me the wrong answer. Well, if that's true, then spoons make me fat. Okay. And there's something wrong with my head from all the hair falling out. I guess it's hairbrushes. Okay. Now, when we multiply this, we're going to end up getting 15. Okay. Not too bad. All right. Moving on. Here's a right here. There's my fraction. So the reciprocal is going to be 9 over 4. Again, I'm using dots. I'm not going to use x's. You can use parentheses, but you're not going to use x's. Okay? So, got to do 9 over 4 to both sides. All right? Use my a. Now, I know it's going to be negative because I have a negative times a positive. So 8 times 9 is 72 divided by 4, 18. Yes, I am using a calculator off screen, and my calculator is also my phone. All right. If we were face to face, I would not want you to use your phone because when you take the ACT, you can't use your phone. But, you know, I always have my calculator with me. During the whole coronation, I was actually doing a lot of math with my phone and actually used my regular calculator for that. All right. So now, still going to multiply because that's what we're doing. Now, I know some other people will say, you multiply by 5, divide by 6. It's the same thing. I have learned that if I teach this method, I actually get more students to get it because it's easier. It takes less steps. Teenagers by nature are lazy. Okay. So I know it's going to be negative because it's a positive times a negative. All right. Now, if I multiply across the top, I get negative 60 divided by 6, negative 10. All right. Yes, I knew that one. I did not have to actually use my calculator for that. Whoop, whoop. Okay. But I am like the worst teacher I can't do math in my head. I have to use calculator. I have to use pen and pencil. Okay. If you're one of those people, you are my people, or vice versa. All right. Now, this is negative 1/2. Well, the reciprocal of negative 1/2 is negative 2 over 1, or just negative 2. So, I'm going to have m. Negative times negative is a positive, and I get 18. Okay. Now, remember, with these videos, if you think I'm going too fast, you can pause them. You can go back and look. All right. Don't sit there, well, I didn't get it the first time. It's there forever. Okay. I will be able to help you if you have questions later, though. All right. 2 steps. All right. We're trying to train you with this because this will actually help us for something later. We're going to undo the add subtract. That's removing the constant term. Okay. And that just disappeared. Awesome. Okay. Constant term. This is our constant is just our regular number. Okay. That's the number without the variable right there. All right. Now the coefficient. All right. The coefficient is going to be the number beside the variable. All right. So a lot of y'all are probably wondering why we're saying all this. There's a reason why when you get to the latter steps and the next couple lessons, it makes more sense. And these steps we have used for 5 years for when we get Algebra for Mastery. It works. And if it's not broke, don't fix it. Okay. So here I'm going to go ahead and highlight. I guess the next color not here is this nice little blue. I feel kind of like Bob Ross sometimes. I don't know where my mark is going. It's disappeared on me. There we go. All right. And okay, come on. There you go. There you are. Oh, I missed. Oh, missed again. Now, I kind of like this because I like this little eraser because I can go whoop, 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 whoop. Pew, pew, whoop, miss, pew, pew. There we go. All right. There's your little entertainment. And yes, I'd be doing the same things if I was in face-to-face. All right. So step 1, undo, add, subtract. So we're going to subtract the 8. Okay. So I'll do that. I'm left with 6x equals. Now this goes away. Okay. I'm left with 42. Now we're to our side by side, or with our division, we're getting rid of that number in front. Okay. So now x equals 7. And this is stuff you can do. I know this is stuff you can do because this is an 8th grade standard. You should have already covered this before the time of the coronation or the fallout or whatever you want to call it, but it is what it is. All right. So step 1, I have to undo the add and subtract. Do that, gets rid of the 5s. Now I'm left with 2x equals 16. All right, so side by side, I got to divide. Dividing by 2, now I have x equals 8. Now, here's another thing, and it's going to be on a lot of the directions. Solve and check, okay? I don't even think I actually solved and checked stuff when I was a student, all right? What that means is you can actually take this, plug it back in, multiply 6 times 7, and then add 8 and see if you get 50. You can multiply 2 times 8 and subtract 5, see if you get 11. Not a lot of people do that. I totally understand, okay? But it's always in the directions because I always have a handful of students that will do that. All right, so my x is over here this time. I've got to undo the add subtract, so I'm going to subtract 9. It's close enough. So I get 4 equals negative 4x. Now, I'm not going to cancel that out right now because you should know that's what's happening. All right, I am going to divide by negative 4. All right, and I'm left with negative 1 equals x. All right, I'm doing what the directions say. It's kind of just take it step by step. If you try to rush through it, because I know some of y'all are like, this is too hard. These are 2-step equations. Trust me, this whole course gets a lot harder, okay? But it's not really harder in definition of difficulty. It's harder by definition of like steps. And I know that teenagers equate more steps to more difficulty, okay? I know that stuff. I know stuff about things. All right. So we're going to add. Oh, I did not add the right thing. I added 9. That's what some of y'all will do. I got to add 7. Okay, I'm going to scroll this up just a little bit so we can see it. All right, so I have x over 2 equals, well, 9 plus 7 is 16. Okay, just a stray mark there. That has not a negative, so I'll fix that for those that don't like it. All right, now I have to multiply by 2. And make sure that's a dot and not a negative. So we have x equals, and this is 32. All right, so 2-step equations. Basically, it's like if the 1-step equations for add and subtract and multiply and divide had a baby, that's what this is. I'm doing the same thing. All right, let's move on to the next slide. Yeah. All right, got a little bit more difficult ones? Not really. Okay, so I'm going to subtract 22. 3 over 5x equals, all right, this ends up being 6. So It's a fraction. That's the reciprocal. Remember the little stick person I flipped upside down? Okay, so I'm going to multiply by the reciprocal right here. 5 over 3, or as I like to refer to it as 5 thirds. Okay, this will end up going away, leaving me with x. Okay. Then, over here, well, this is 6 times 5. That's if I'm not using a calculator. Okay, 6 times 5 is 30, divided by 3 is 10. Awesome. All right, moving on. There's my, now I didn't mark the variables, but you can if you need to. Subtract 1, subtract 1. Okay, I have 1/3. X equals, this is going to be negative 8. All right, again, if you don't understand how to negative 7 minus 1 is negative 8, use your calculator. All right, in class, I would actually make fun of people that didn't use their calculator. I know that sounds mean, but sometimes some people don't respond very well to, oh, dear heart. Okay, so negative times negative is going to be positive, and then 24. Okay, so again, two-step equations, not bad. We just had some with fractions. Don't let fractions scare you. Okay, I know 5 out of 4 people have issues with fractions, but they're not that bad if you take it one step at a time. You're not photomath. You can't do all this at once. All right, how do you solve this two-step equation? Dun, dun, dun. Well, let's kind of think about it. I want to kind of zoom in just a little bit. Okay, so if we look at this, come on, it's thinking. There we are. All right, so right here, x is on top. Don't let that freak you out. You should not actually subtract 5 first, okay? Remember, you have to undo what's being done to the variable. Variable's here. Ooh, big spot. All right. So I'm going to sit here. This is actually all being divided by 3 first. So I'm going to multiply by 3. Yeah, I don't have a lot of room right there, but it's all right. So when I multiply by 3, that goes away. I'm left with the x minus 5 right here. 2 times 3 is 6. Then add 5, add 5. Okay, and then x equals 11. So with these, I kind of think about like this. When it's a big fraction, you multiply first. When it's a big fraction, you multiply first. These are big fractions. All right. So this is all being divided by -2, so I'm going to multiply by -2. Okay, this gives me -28 equals 6 plus z. And yes, I'm one of the weird people that do the line through the z because I have bad handwriting. Okay, plus I had a professor in college that used to take off if I didn't do that. All right. So moving on, this is going to be -34 equals z. All right. So not really that bad. All right, just a little bit more. But going on from here. All right. Oh, word problems. All right. You will have word problems this semester. All right. The word problems will match up to what we're covering. All right. It's not going to be anything super difficult. Actually, like on the homework, that's for the Delta Math, and there's a link to that. You'll be able to click on it. It kind of helps you through this. It's very set up very similar. Okay. So first thing we have to read is the directions. Define a variable, write an equation for each situation, and solve. All right, online DVD rental offers gifts. All right, so this is an awesome statement right here, but we don't need it. Okay. I have a gift certificate for $75. The plan costs this much per month. How many months can we purchase with the gift certificate? All right, so think about how many months. That's going to help us define our variable. So I'm going to say M equals months. Now, you could use X if you want to. Totally fine. Okay. Now, when we're setting up our equation, we need to think about What's given to us? Well, we know it's this much per month. Usually when you see this word per, this is going to be multiplied. So 6.25 M equals, and we have $75. There's our equation. All right. All we have to do is just divide from there. Okay. So 6.25. If you notice my eyes looking over to the side, yes, I am using a calculator because I cannot do this in my head. All right. And when we get this, we end up getting M equals 12. All right. So with that $75 gift certificate, you get 12 months. Basically, it's like when Disney Plus started. If you had Verizon, you could get it free for a month. This is very similar. This is just the equation behind it. Okay. All right. Moving on. Oh, more word problems. All right. 33 students went on a field trip. Yay for them, even though that's not going to happen now. 6 buses were filled and 7 students traveled in cars. How many students were on each bus? Okay. So let's start with the question. How many students? Okay. So I'm actually going to say X equals students. Number of students. That's not hashtag. Okay. Number of students. Well, let's set our equation up with what we know. Okay. Well, we know that there were this many students on the field trip. So that is what our total should be. All right. We're asked for how many students were on each bus. Well, how many buses did we take? Well, 6. 6x. And then we had 7 students in cars. Okay. So this is actually how this equation is set up. Now, I have a feeling that if you were just given this, you could solve it all day long, no problem. But setting it up is the hardest thing. All right. So we're going to have 331 minus 7. I should be able to do that in my head, but I can't. 324, 6x. Now we're going to divide. All right. So we end up getting x equals 54. So there was 54 students on each bus. That's it. Now, I kind of like this word problem better because we didn't have to really mark anything out. And we kind of wrote our equation based on what they gave us. They gave us the total students. They told us there were 6 buses and 7 students tagged along in cars. And then we're asked for students in each bus. So when you set up your equation, you need to think about, is this going to help me how I set it up? Is it going to get what I'm asking for? Okay. Yes, some of these are dated. I do kind of laugh at this one all the time. All right. It says that student won 40 fidget spinners playing cornhole at a pregame festival at JCH game. All right. Basically, only thing we need to know right here is the 40 fidget spinners. Okay. That's kind of funny because that's not really a thing anymore. Hopefully not, unless you actually need it. All right. So we don't need to know how she won them or she stole them from somebody, but that's just it. All right. So later, she gave 2 to each of her friends. So we need to know this. And then she has 8 remaining. How many friends does she have? All right. So I don't know why this is gone right there. Oh, that's great. I'm allergic to something. That's awesome. Oh, that won't go away. Neither will the sneezing. All right. So I'm going to find my variable. I'm going to say x equals friends. Now, the running joke on this is that if this was Mr. Jeffries, he would still have all 40 fidget spinners because I don't have any friends. That's kind of funny. All right. So we have 40 fidget spinners. Okay. She gave 2 to each of her friends. So 2 times x. All right. And then she had 8 remaining. That's how it works out. Kind of simplistic. I love it. I'm a simple person, believe it or not. We just solve it like we normally would, minus the sneezing and all that other stuff. And no, I'm not going to edit all that stuff out. They're going to be as close to what you would see me doing in class. Okay, so she has 16 friends. Okay, to me, that circle is too much. Either that or she just had 16 people that came up and asked for fidget spinners. Because I know a lot of people say, oh, you have something, I should have it too. No, that's not how the world works. I'm sorry. That's just, nope. All right. So the junior class is selling granola bars to raise money. They purchased this many granola bars and paid the delivery fee of this much. The total cost, including delivery fee, was this. What was the cost of granola bars? All right, so we know that we don't need to know that the junior class is selling granola bars. Okay. We do need to know the following information. We need to know this right here. We need to know that they paid this. We need to know the total cost including this was this. Okay. I did not pick my nose. That's scratching my nose. If I picked my nose, my finger would be way up there. I know what you're thinking. All right. So we're going to say X is cost per bar. Okay. I'm not going to spell out granola because you wouldn't do it either. Okay. So we need to know, well, this is how many they had, right? And the delivery fee, no, let's not do that. This should be beside our variable because that's how many we bought. And we're trying to find out the cost per bar, right? Think about it. All right, they paid this much and the total was this much. All right, so we're going to subtract. That's $7.75. All right, now, forgot my X. Hopefully nobody would do that also. Now, we're going to divide by this number right here, 1,250. So 775 divided by 1250. All right. Let you know, you are going to get a decimal. Okay, you're going to get a decimal. Decimals exist. If you go to the Publix or the Walmart or something and buy, very few times I've ever gotten something that's been exactly it. Okay, and if it does, I usually kind of ask them to double check. All right, this one always causes a lot of questions in class. All right, you have a $16 coupon. You have $16 and a coupon for a $5 discount. It actually helps if you read the problem correctly at a local supermarket. A bottle of olive oil costs $7. How many bottles can you buy? All right, so we're going to say, think about it. We're asked for bottles, so X equals bottles. Okay, now, how much money do we have at the beginning? $16. Okay, they cost $7 each. Now, this $5 coupon, this is where people could actually set it up two different ways. Some people are going to think, well, that's like saying I have $16 plus $5. Or some people are going to set it up like this right here, that I actually have this minus that. Either way is fine, because I'm going to show you something. If you set it up this way in red, you're going to end up with a green one anyways. Okay. We end up getting, okay, 3 bottles. Okay. I don't know why somebody needs that much olive oil unless you're running a restaurant. But the big thing about that is, who cares about what we're buying or why? Is how we set it up. Remember, a discount is subtracted from the total. Or we can, It's like if you have a $20 gift card to Amazon. Well, it's whatever you're buying minus $20, or you're adding to whatever you have. All right. And that's it. Okay. So don't forget to check the link right there for what you're doing, and then we'll be good to go.